Hi friends, Chloe Madison here, aka Clomads. Today I just wanted to talk a little bit about some lamps that I'm working on. So this is a concrete base lamp, and the top is 3D printed and separated into two parts for a switch. Currently no lighting in there right now. This does have currently have a cork base, but I have some vinyl that I actually want to put on here instead. 1 second. There we go. Vinyl that I'm going to laser out using the 3D printer. I have an attachment for a laser that I'm going to cut out a bottom for this, as well as this lamp, which is a larger version of this lamp. Aren't they fucking cute? Yeah. Anyways, so my final portion of research is going to involve, it has to involve the lighting aspect, the LED lighting aspect of it. And the main problem that I've been running into is that with higher power LEDs that you need a constant current voltage source or constant current power source, rather than what you would do with lower draw LEDs, where you just put a resistor in line with it, which also is has a tendency to be a problem, mainly because if you have an array of, like, let's say 8 LEDs that are SMDs, you're going to have to do an additional array of resistors for those as well. And plus, resistors are just not efficient, so you're going to lose a lot of energy through that resistor to just being heat. So all it does is it offsets the power that's coming in by getting rid of it as heat and then sending the right amount of current to the LED. That's a very simplified version, but what I found is this. Well, this is running right now. I'm going to actually turn this off, but these little guys, if you can see that, let me try to focus here. That is a constant current LED driver, and you have your input and your output and a ground. Additionally, you have a select switch, so this can actually run on standard constant current algorithms, I guess you could call it, or it can adjust the output to a PWM signal. And all of that with one chip and a resistor and potentiometer trimmer pot. Which is good, because a lot of these constant current, like if you get these chips, a lot of the times the data sheets require you to have a lot of extraneous components, capacitors, resistors, whatnot, and this one just requires 2 additional components. So I'm probably going to initially do my builds with just these soldered to a custom circuit board, so this can end up going in here on a circuit board. And then that can have the places for my additional components, the LEDs that I'm using, which I'm still researching through. I have a ton of different LEDs. I have these flat cobs. I have this style. I don't know if you can see that, but I'll put links for all the ones that I've been looking through over the past few months. Down in the description. But today, sorry for taking so long, I wanted to play around with this. And this is possibly one of the best lamps that I've ever found on Amazon. It was $25. It's got a battery in the base. It's got 2 charging ports. It's very bright, as you can see. And it's got a little bit of it's got a capacitive touch button, so you turn it on and then you can hold it and then it dims, which is actually not my favorite feature. I'm more of the type of person where I want a clicky switch on and off. But this is so well made. I want to investigate what's going on in here. And so I'm going to do a teardown. And I've been wanting to do this teardown for a while, but I've been hoping to do it on camera with y'all. So join me as I start ripping this thing apart. I do actually, you may see in the background here, I have another one there behind me. And these are so good. They'll charge your phone off. You can charge your phone off of it, all for $25. And it's got a 4,000 milliamp hour battery apparently in there, and I've tested charging it, and it's rock solid. Definitely gonna put this lamp in the bottom just because it's such a good product, and I would love. I just love sharing good products with people, especially when they're at a price like $25. You can't even get a battery bank, a 4,000 milliamp hour battery bank for $25. Well, maybe, okay. Maybe I lied. You can, probably. Some of the 10, 20,000 are like $30 or $40 from Anchor. But still, like, there's a lot going on in here. So, what I'm doing right now is I'm taking off the adhesive. There's like a rubber pads on the bottom. I don't know if you can see that. And I'm just trying to peel off them so that I can have access to the screws that are holding the bottoms together. So maybe this tool will help get these off a little bit better without them ripping. There we go. 3 on that side. Let's see if there's any more under this. Yep. 3 on each side. Let me poke out this adhesive a little bit. Ultimately, I really just want to see like what type of circuitry they're using, because this actually gets pretty bright, and I'm really trying to balance like power consumption versus brightness. Figure out which LEDs I want to use. I'd like to see what LEDs they're using, and whatnot. So if I can find my damn screwdriver, I'm going to go with a smaller head. Get this out of the way so maybe you can see some of what I'm doing. In case you are wondering, the screwdriver that I'm using is called the I forgot the model name. ES120. It's an open sourced mechanical or motorized screwdriver for stuff like this. See if I can get those screws out. Oh, it's gonna fall out like that. That looks good. And do a couple more turns here. Sweet. Alright, we're in. Oh, it's got a chunk of metal on the base, which is great. You gotta have a big base for that. That's awesome. Very large lithium ion battery in here. Like, I don't think I can get this lithium ion battery for any cheaper than like $10. Maybe $4 or $5. And maybe in quantity, maybe like $3. But still, there's so much that's going on here. This is just a little padding that's on the inside here. I'm looking around. If you look at the circuitry in here, I we've got a little bit going on. I'm going to see if I can find some of these 5305. We've got a 5305, a I'm guessing a lot of this stuff is going to be charge control. In fact, I'm going to continue tearing this down before we get a little bit too far into it. I don't want to make too many assumptions about what's going on with this thing until I've had time to really sit down with it, but we can kind of take a first look at what's going on and then move forward from there. I think I am, just to be safe, going to desolder this battery. This is also an open source soldering iron. This is called the TS100. Super popular. You're going to find it under a bunch of different brand names. If you just Google for TS100, you can find it coming from China, or even on Amazon you can get them too. They're going to be a little bit more expensive on Amazon, and but they'll get to you quicker. So this is a great soldering iron, and I will fight anybody who tells me otherwise, just because it's so freaking good. It's just powered by a DC power jack on the back, standard 5.5 millimeter DC power jack. It's got firmware on it. It's got a little OLED display telling you what your temperature is. There we go. Get that fucker out of there. Get out. Yep, you're done for. You're done for, friend. And then pull another one. This other one out. Get some tweezers first. Anyways, you can upgrade the firmware. I've even seen somebody put Flappy Bird on this display, which is hilarious. So, you're not going to be able to use it as a soldering iron if you put that firmware on there, but pretty funny that they decided to do that. Yeah, so we have a capacitive button here. This is just a capacitive switch with the coil that comes up to this, which is just a feature of the casing. And then over here we have the main board, which it's connected to. Let's see if I can get this out here nicely. And I am going to want to get into that top part at some point too. Unfortunately, I see what's going on here. There we go. There we go. Wow, that's actually really good. So they took this little wire here. I don't know if you can see that or not. Let's get focus here. Right here, they took this wire, and this wire is coming down from here, so it's going straight in and then actually through a hole in the main board there. And it's they left enough length for being able to manufacture this and assemble this, but they actually what they did was, once they soldered it, they twisted it up and then put it around this capacitor like that. And yeah, that's actually really, I don't know if that's good. I mean, mechanical strength, but there's no mechanical issue with it being there. It's just there to clean it up. So actually, I'm pretty impressed by that design. I am going to have to desolder. Oh, that just came off. Desolder this, which is the leads up to the lamp. So all the controls Sorry guys, limit on the camera recording time. So honestly, this looks really good. I'm sure all of the circuitry for the lamp itself is on here, but I do want to actually see what's going on inside of the head once I get this board out. So yeah, we have, let's see here. Oh, that's pretty messy. Not as clean on the back side as I expected, but not too bad, not a problem really. From what I can tell, they've got their USB ports as thin as possible. They've actually recessed their USB ports into a slot on the board, and those end up, wow, those are really good. Those are really, okay. Couple unpopulated slots. I will upload a picture of this board in a little bit, but so y'all can kind of like take a look at it and see what's going on with it. But meantime, I'd like to crack into this side of things and see what's going on in here. And I don't see any ingress points here, so we're probably just gonna have to start popping things off or breaking some plastic. Oh, there we go. I got a little bit going here. Yeah. Where we go? Oh, nice. Okay. I see how that is. So this little thin piece of plastic just kind of meshes in there and then clips on. Everything else is connected right here. Oh my gosh, really? Oh my gosh. That is brilliant. Let's see here. Let's see if I can get this out so I can show you what's going on here. Oh yeah. Come on, friend. All right. So 23, 24, D1. All right. So, interestingly enough, we have an LED strip inside of there. You can see the light coming in because this part is frosted right here, and then this is a diffuser, so this allows the light to bounce through it evenly. So it's like this in there, and it's gathering light from the edges and then spitting out light through here. So that would go in there like that. That is a really nice design, and I am impressed that they were able to, I guess that makes it cheaper. I mean, they don't have a custom board up here, they just have LED, like a flexible PCB lighting strip with 24 LEDs on it. So that's actually really cool. I'm glad I opened this up. I am planning on doing a little bit more research on what's going on with this board because there is no additional circuitry up here. There's not even resistors or anything on these. So these are probably very likely all in parallel or it looks actually as if these are all in series, and I would like to see that because, yep, the whole thing is yeah, there's 24 LEDs in series, so they have to up. Why did they do that? I'm going to do a little bit more research I don't know why they would put them in series. I'm gonna do a little bit more research on that. That's a heavy piece of metal. And I'm gonna see what we're getting out of this. In fact, let's do an experiment. So this plugs in here. And then we get voltage buddy. That's positive and negative right there. It's lighting my LEDs over there. I'm not getting a voltage off of this for some reason. It should be though. There we go. 2.64 volts. But wouldn't we get a voltage drop? Or since it's a constant current, is it going to bring up the voltage across the entire thing to do the thing the way it things? If you want to hear more about this, I guess leave a comment in the description below. I'll put a picture of this up on my Instagram, and y'all can take a look and see if you can do a little bit of reverse engineering on this cool little lamp that I've now taken apart. I could probably put it back together, but for now, I want to keep these components up. I got another one over there, and we'll see what we come up with as multiple people look at this and see what's going on here. I could probably look up the data sheets on these little chips too, and see what's going on with those. So I'm gonna leave y'all to it. This has been, I don't know, what is this? Infodump number 4. I'm Chloe Madison, Chlomads on Instagram and Twitter, and I am on Queered. Well, I'm not on Queered.com. I run a site called Queered.com for queer and queer trans people of color, artists and makers to show off their work, and hopefully we're going to get some makerspace here in the Bay Area soon, preferably in Oakland. And Voidbox VDBX.io, or currently VDBX.io on Twitter and Instagram, to check out the latest electronics projects that we're working on and going to be delivering to you in an open source format. So if you like this video, give it a thumbs up. If you didn't, I guess give it a thumbs down, hit the subscribe button, and I will see you in the next one. Bye.